everyone, this is Dr. Apogee. In this video, I'll be doing a quick review of my recent launch of the Katana rocket. This launch took place at the Higgs Ranch as part of the MDRA launch over the January 7th and 8th weekend. My wife and I drove to a hotel near the launch site and stayed there Friday night. I was up bright and early on Saturday to do the final preparation for my two rockets. One of the most important systems in the high-power rocket is the electronics. Here you see my almost completely assembled electronics bay for the Katana. I use the RRC3 controller to control the drogue and main releases. I customized the mounting hardware using some plastic screws and parts from the electronics store. You can see I have a side-mounted push button to control power of the board. I use a small piece of dowel or piece of bamboo through a hole in the tube to switch the power on and off to the RRC3. The chargers are held in the PVC cups at the end of the eBay bulkhead. I pass the wires through the controller and then seal the holes with some electrical tape. This lid from the plastic box served as a great surface to assemble the hardware at the hotel. Once the electronics bay is buttoned up, it's time to attach it to the upper body tube. Here you see the electronics bay after I completed the wiring to the charges. You can see the holes in the body tube and the electronics bay. These holes are where the rivets go to make the connection between the E-bay and the tube very secure. I used 8 rivets to make really sure the system doesn't come apart due to aerodynamic forces. You can also note the hole in the white switch ring. There are several holes in the ring to allow air in for pressure sensing and to provide access to the power switch for the RRC3. Both the main and drogue chutes are in the slide. You can see they're in their packing baggies next to the body tube. Here you can see I put the rivets into the upper body tube and the electronics bay. You can see I've marked the electronics bay and the body tube to make it easier to align the two items for the rivets. There are 2 sets of rivets, an upper set of 4 and a lower set of 4. If you're careful, you can remove the rivets after the flight and carefully compress them with a pair of pliers and use them again in another flight. Properly packed chutes are essential for a good recovery. I learned this lesson the hard way when I had some hard landings due to tangled lines and other errors. I found some excellent videos online on chute packing and follow the same procedures now. I make sure the lines are straight and not tangled. I carefully fold them into the chute as shown, and then I fold the chute in sideways and roll and fold it down. This method's worked well for me in the last 5 or 6 launches. The hotel floor provided a good long area as this is a 58-inch chute and the lines are rather long. Here's the upper part of the Katana. After the E-bay is connected, the upper harness is connected, and the chute is folded and put away. That's a lot of work, but it's essential for a good recovery. I have some blue tape to hold the nose cone to the upper body tube, as you can see. I didn't have shear pins for this launch. Luckily, several pieces of blue tape held the cone on for this flight, but for future flights I'm going to use shear pins to be absolutely sure there's no problems with drag forces removing the nose cone prematurely. Having a good motor is another important factor in a good flight. Apogee Components, the designer of the Katana, has a list of recommended motors on their site for each model of rocket that they sell. The list includes an estimate of the maximum altitude the rocket will reach with each motor. Of course, your altitude may vary. Another good tool that I use is the RockSim software. I use this with the vendor-provided design file and motor files to get a flight profile before the flight of the Katana. This way, I was confident that the rocket would have a good flight and that, if the dual deployment system worked properly, the rocket would land fairly close to the launch site. This particular motor is a single-use 54mm Aerotech motor. I like these because they're really fast and easy to load and go for a flight. The disadvantage is that they're more expensive than the reloadable motors. The values on the motor can be instructive, such as the peak thrust. Be sure the peak thrust for the motor is sufficient to account for the mass of your rocket. Note this rocket lists a delay value. By adjusting the delay with the proper tool, you can adjust when the charge that comes to the motor will fire. But I found this to be unreliable for motors above the H size. So I didn't load the provided charge or adjust the delay. Instead, I used the RRC electronics to good effect on this flight. The Katana is here, leaning up against the back of our vehicle at the launch field. Note that I haven't loaded the motor yet. This is always the last step before going to the RSO desk for weigh-in and final review. You can see I use plastic containers to hold things for the flights. I found that small shoebox-sized containers nest pretty well in larger containers and allow me to have everything well organized for field use. This organization saves time and avoids frustrating delays and missed launch opportunities, as I've learned. You also can see in the back of the vehicle the lower part of Big Cat, another rocket I built, specifically the fins. There'll be more about that rocket in another video. It's really handy to have a helper when it comes time to mount the rocket on the rail. My wife staked out a prime launch site for me while I was working on the second rocket and ensured that I got my chance to fly the Katana. The phone camera here was on wide angle mode, so the area that's behind the rocket looks much farther away than it really is. I had to put the camera on wide angle mode so I could get the whole Katana in the field of view at once. It's a pretty tall rocket. Of course, the area behind is a safe distance away, and everything meets all the requirements of the NAR. You can see my wife is here holding the baggie that has the blue tape, igniters, and other goodies in it. This is essential to make sure that we don't get way out in the field and forget something important. I couldn't do the flights without my wife's help.
The Katana apogee kit on a J250. Drogan apogee mains at about 500, 7-pound rocket. It's tall, it's orange. Here we go with the Katana. In 5, 4, 3, 2, 1. Ooh, you hit the blue patch, or I would have lost that for sure.
Here's the video of the launch taken by my cell phone on wide angle mode. I want to make sure I could get as much of the takeoff as possible, so that's why I set it to wide angle. The Katana had a great takeoff into the patchy, cloudy blue sky. The Katana soared into the sky, and we had to look hard to see it at first. The orange color helps to make it a little more visible even at altitude. We watched as the rocket separated apogee, pulling out the small drogue chute. And we waited anxiously until the controller fired the charge and the mains came out at about 500 feet. Thanks to dual deployment, the rocket came down less than 200 yards from the launch site, so I only had to worm through the brambles once and across a second field to recover it. Here the Katana rests on some nice green grass and is visible from some distance away. Thanks to the RRC-3 and dual deployment and to the care I took in preparation, the rocket came down near the site intact and very usable and will fly again soon.